Hi, good morning, guys. So today we're going to get started on lesson 10.5. It's a 2-day lesson, all right? So I will post the blank notes, the copy of the blank notes on Google Classroom along with my answer key, all right? Just like I've been doing, I'm not going to write the vocabulary, at least all the vocabulary. Some of this I'll just be kind of reading and going through with you, and then some of them I'll be doing up on the board, okay? I kind of already got it started, but if you take a look at the vocabulary, the first term is permutation. Okay, and I very briefly wrote order is important. Okay, a permutation is an arrangement of objects in which order is important. And we're going to talk about different examples of permutations, but one example of permutation, actually, the first one we're going to talk about, is if you're running a race and we're talking about how many different arrangements are there for first, second, and third place. Okay, when you run a race, whoever finishes first earns first place, second person is second place. So the order in which people finish the race is important. So that would be an example of a permutation. All right, the next vocabulary term is n factorial. The product of the integers from 1 to n for any positive integer n. So I'm going to take a minute and just stop for a second and go over to the board, just jot something down. If we talk about 5 factorial, the way we write that is like this. That's 5 factorial. And that notation just means to take the product of 5, 4, 3, 2, and 1. So it's 5 times 4 times 3 times 2 times 1. Okay, which we can simplify. 5 factorial is 120. If we were going to do 4 factorial is the product of 4 times 3 times 2 times 1. So 4 times 3 times 2 times 1. So 4 times 3 is 12, 12 times 2 is 24, 24 times 1 is 24. So 4 factorial is equal to 24. There is a button on the calculator, and I'll show you where that is now. So again, 5 factorial, which we could just, knowing the notation, you can multiply 5 times 4 times 3 times 2 times 1 to see that it is 120. Or if you hit 5 and then you're going to hit the math button and scroll over to probability, and go down to the 4th option, or just push 4. 5 factorial is equal to 120. Okay, so that's important to know for the lesson today. All right, that was my little side note there. All right, next term is a combination. A combination is a selection of objects in which order is not important. So we'll talk about that in a few minutes. Okay, then we have formulas. So the formula for permutation is NPR, which is n objects taken r at a time, and it's equal to n factorial. So we're going to fill in numbers here depending on the problem. N factorial divided by n minus r factorial. Combinations use the formula NCR, n objects taken r at a time, and it's equal to n factorial divided by n minus r factorial times r factorial. Okay, so the first example today, it says 10 horses are running in a race. In how many different ways can the horses finish first, second, and third place? Assume no ties. All right, so the first challenge, what you're going to have to do for these problems is determine, is it a permutation or is it a combination, okay? So you have to ask yourself, is order important? Does the order matter in this problem? And I kind of already spoke about this, but yes, order does matter because the first horse earns first place, the second horse earns second place. There is importance in which they finish first, second, third. It'll change the outcome. Okay, so it is a permutation problem. So since it's a permutation problem, we're going to talk about what are the objects taken how many times. There are 10 horses, so that would be 10 objects, and we're considering first, second, and third place, so taken 3 at a time. So we'll write that in words, 10 objects, which are your horses, taken 3 at a time. And where did I get the 3 from? That's first, second, third place. Okay? So the 10 is your N, the 3 is your R. So for this problem, it's going to be 10 3. I'm going to show you how to algebraically longhand write it out. So it's 10 factorial over, and then it's 10 minus 3 factorial. We're going to simplify inside the parentheses first. So 10 minus 3 will give you 7 factorial. So now I have 10 factorial over 7 factorial. Now notice how I'm going to write it out the next step. So in the numerator, I'm going to write this as 10 times 9 times 8 times, and I'm going to write 7 factorial over 7 factorial. So I didn't go all the way down to 1. I stopped at 7 factorial because I knew the denominator was 7 factorial. Those now cancel. So I'm just left with 10 times 9 times 8, which gives you 720, right? Yep, 720. So there's 720 different ways that the horses can come in first, second, and third place. Okay. We actually could also, for this problem and for permutation problems in general, use the fundamental counting principle that we used earlier in the chapter. If we're looking for the possible outcomes, the number of possible outcomes, right? If this is first place, if this is second place, and if this is third place, there are 10 horses that could come in first place. There are now 9 horses that could come in second, and 8 horses that could come in third. Multiply together and you'll get your 720. Okay, so it's just another faster probably way of thinking about this problem. All right, let me get the second problem set up for you guys. The next example says this. You order a sandwich and can choose 2 side dishes from a list of 8. How many combinations of side dishes are possible? Okay, so it does give it away. It says how many combinations, but if we think about, is order important here, okay? And you're going to see a lot of word problems where it talks about ordering pizza with different toppings, or ordering an ice cream sundae with different toppings. In this case, ordering a sandwich with 2 side dishes, right? If you go to a deli and you say, I want a sandwich with a side of potato salad and coleslaw. It doesn't matter if you say potato salad or coleslaw or potato salad, right? The order in which you order your side dishes isn't going to change the meal that you're going to get. Same thing with ordering pizza. If you say I want a pizza with pepperoni, sausage, and onions, right? Or if you said onions, pepperoni, sausage, you're still going to get the same pizza, okay? So this is an example of a combination because order is not important. All right, so we're still going to talk about n objects taken r at a time. Okay, so if you have 8 side dishes to choose from, that's your 8 objects, taken 2 at a time because you're going to order 2. Okay, so we'll write that down in words. 8 objects taken 2 at a time. So following the combination formula, it's going to be 8C2. So you're going to have 8 factorial over 8 minus 2 factorial times 2 factorial. Okay, so we'll simplify a little bit. You have 8 factorial over 8 minus 2 is 6 factorial times 2 factorial. Just like the last problem, I'm going to expand a little bit so I can then simplify. So 8 factorial, I'm going to write it as 8 times 7 times 6 factorial, but then I'm going to stop. And the reason I stopped at 6 factorial is because I knew that there was a 6 factorial on the denominator that I could cancel with. So now I have 8 times 7 over 2 factorial, which is 2 times 1. All right, running out of room over there. So you're going to have 8 times 7, 56 over 2. And then 56 divided by 2 gives you your 28 different combinations of side dishes that are possible. Okay. I did want to show you the calculator for both this problem and the last. So I wanted to show you how to simplify by hand, but then also in the calculator for this problem, if I hit math and then go over to prob, you may have noticed when I was showing you the factorial, options 2 and 3, right? There's your permutation, there's your combination. So if I select the combination, so I can show you with this problem, it allows you to plug in the number of objects, which is 8, taken 2 at a time. And you can see the answer is 28. Okay, for the first problem, which was the permutation, 10 horses, 3 places. So I'll show that one as well. So go math, go over to prob, go down to permutation, 10 horses taken 3 at a time, and we said the answer was 720. Now, if you have the older versions of the TI calculator, TI-84, but like the bigger ones, I think what you have to do is you first have to put in the, 8? So you'd put in 8, then you'd hit your math, go over to prob, combination, okay, so that it would be in the right spot, and then push the 2. Okay, so you might have to play around with your calculator to figure out exactly how you need to input the information, but I wanted you to know that they were there. All right, we have 2 more problems to do. Okay, so the next problem I think for this one, I'm just going to read it to you because it's kind of a long word problem instead of writing it all out. And you guys can follow along because you have the notes. All right, so it says, a yearbook editor has selected 14 photos, including one of you and one of your friend, to use in a collage for the yearbook. The photos are placed at random. There is room for 2 photos at the top of the page. What is the probability that your photo and your friends are the 2 placed at the top of the page? Okay, so we need to know how many outcomes there are. And since this is a combination problem, we're going to use our combination formula to figure out the number of outcomes. All right, so that's the first thing we're going to do. How many outcomes? All right, so since there are 14 photos, that's 14 objects, taken 2 at a time. All right, so it's 14C2, and you can use your calculator and plug that in to get 91. Okay, there are 91 total different combinations on how many collages, I'll say, how many collages there are. Now, out of those 91 collages, what's the probability that your photo and your friend's photo are chosen? So probability you and friend. There's only going to be 1 out of those 91 outcomes where it's you and your friend that are selected. Right. And the last problem, spread. Okay, so the last problem, it says, for a town parade, you will ride on a float with your soccer team. There are 12 floats in the parade, and their order is chosen at random. Find the probability that your float is first and the float with the school chorus is second. Okay, so we're going to again talk about how many outcomes there are, and then we'll find the probability. All right, so let me get my marker open. Hold on a sec. Oh, there we go. So for this example, how many outcomes? Okay, so if there are 12 floats, right, we can use the counting principle for this. So this is the first float's going to go second all the way down to 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, go this way, 10, 11, 12. 12 different floats to choose for the first spot in the parade, then 11, then 10, then 9, then 8, then 7, 6, 5, 4, 3, 2, 1. Right? So the total possible number of outcomes, 12 factorial, that would have been the easier way of writing this, 12 factorial, is 132. Okay, so there are 132 different outcomes of how the floats can be arranged in this parade. And it's asking, what's the probability that the soccer team is first, followed by the chorus being second? Well, out of those 132 possible arrangements of how the floats can be in the parade, there's only going to be one arrangement where the soccer team goes first and the chorus goes second. So the probability is 1 out of 132. Okay. Now, for those last two examples, I tried to show the most simplified way of going through them. If you take a look at my notes, there's a little bit more detail, so or different ways of thinking about and setting them up. But I tried to show you the easiest, most straightforward way. All right, that's it for today. I'll see you back here tomorrow. Bye.